In this lesson, we're going to cover volume of pyramids and cones. So we have the volume of a pyramid is going to be 1/3 the product of the area of the base and the height. Because of Cavalari's principle, the volume formula is going to be true for all pyramids, including oblique pyramids. The height of an oblique pyramid is going to be the length that is perpendicular segment from the vertex to the plane of the base. The volume of a cone is also going to be 1/3 the product of the area of the base and the height of the cone. So let's look at some problems and learn how to apply our formulas. So starting off in number 1, here we have our square pyramid. And so I'm going to start off by just highlighting my base real quick. Okay, so we are going to start by finding our capital B, area of the base, which, as I mentioned, this is going to be a square. So we could do base times height, or we could do our side length squared, so 7 squared, which will give me 49. Then we have our h, our height, is going to be 10. So when I plug in to find the volume, I'm going to have that 1/3 of my area of the base, 49, times my height of 10, which 49 times 10 is going to give me 490. And then we're just going to leave it over 3 because it's not going to reduce any. And then we'll have our units cubed, so centimeters cubed. Remember, we want exact answers only, and preferably leave them as the fraction, because sometimes you can't change your fraction into a decimal without having to round it. All right, let's look at number 2. So for number 2 here, we have our cone. We have our base is going to be this circle down here. And so if we look here, we can find our area of the base, which is pi r squared, and they give us that our radius is 9. So we'll have area of the base is 81 pi. Then we need our height. So looking at it, this 15 feet, remember, is your slant height. So we want to find our h, our height that is perpendicular to the base. And so we are going to use Pythagorean theorem to solve. We'll have our 15 squared is equal to 9 squared plus b squared. So we'll have 225 is equal to 81 plus b squared, which when I subtract is going to leave me with 144 is equal to b squared. Therefore, my b is equal to 12. So we can plug into our volume formula. We'll have that 1/3 81 pi times 12. Well, 1/3 of 12 is going to give me 4. And then that 4 times 81 is going to give me 324 pi. And we'll have our feet cubed. Okay, let's move into number 3. So for number 3 here, we have that our base is going to be this triangle here. It is a right triangle. And so we are going to start off with our capital B is going to be found by using 1/2 our base times our height. which is going to be that 18 and 22. So half of 18 is going to give me 9. 9 times 22 is going to give me, we'll have 198. Then we have our H, which is that 13 inches. So for my volume here, we'll have 1/3 the area of the base, the 198, times 13, which when you multiply all that together, you should get 858 inches cubed. Okay, moving into number 4 here. For number 4, we do have a composite figure. We have a cone on top of a cylinder. So once again, I'm always highlighting my bases. Just helps me kind of find everything that I need. So I'm going to start off with my cone. We'll find our volume of our cone, and then we'll just add it to our cylinder. So for my capital B here, we'll have our pi r squared, which they give us our radius is 3. So 3 squared times pi is going to give me 9 pi. And then my H is going to be the 4 centimeters. So finding my volume, I would have that 1/3 of 9 pi times 4, which should give you 12 pi. Then we have our cylinder. It has the same base, so my B should also still be that 9 pi we found earlier, but we'll have a height of 7. So finding the volume, we would have that 9 pi times 7, which is going to give me 63 pi. So to find the volume of this composite figure, we are just going to add these two together. We'll get the 12 pi plus 63 pi, which is going to give me 75 pi. We'll have our centimeters cubed. All right, so now let's look at number 5, our next problem. And so for number 5 here, we will see that we have another composite figure. We are going to have a square pyramid on top of a cube. So let's see what we can do to find our volume. We'll start off with our pyramid. Okay, so for our capital B here, we're going to have the area of the base, which is just going to be 12 times 12, 12 squared, to give me 144. And then we have to find our height. So our height should be perpendicular to the base. So that's the line I'm drawing right now. And with what we currently are given, we are going to create a right triangle with it. And we actually know our lateral edge, not our slant height. So I am going to be using this diagonal length of the square and not the one that's using half of its side, because of the fact that it's our lateral edge and not our slant height. Okay, if it was our slant height, I would just use half of that 12, but it's not. So I'm going to use my special right triangles, my 45, 45, 90, to say that this is our S. This would be S root 2, which would make that length 12 root 2. Okay, but we are only going to use half of that, and so we will take that 12 root 2 and divide by 2 to get 6 root 2 for what we will use in our Pythagorean theorem. All right, so let's do our Pythagorean theorem. I'm going to just do it over here. We will have our 10 squared is equal to our 6 root 2 squared plus our b squared. Okay, so when I square everything, I'm going to get 100 is equal to, and so here we're going to have our 36 times 2 plus b squared. Well, 36 times 2 is just going to give me 72. So I'm going to have 100 minus 72, subtract it over, should be equal to my b squared. And when I subtract, I am going to get 28. So I'll have the square root of 28 is equal to that b, which we then need to simplify. So I would have 2 and 14, and then 2 and 7 to get that my b is equal to 2 root 7. So we're going to have a height of 2 root 7 for this pyramid. So plugging in for our volume, we would have our 1/3 of that 144 times 2 root 7, which will give us a volume of 96 root 7. Now we need to do the volume for our cube. So our capital B is also going to be that 144. We're going to have an h, a height of 12. And so our volume is just going to be 144 times 12, which is going to give us 1,728. So to find my total volume here, we are just going to add those two together. So we'll get 1,728 plus the 96 root 7 feet cubed. All right, moving into number 6. So for number 6 here, we have a cone that is just going to be an oblique cone. Noticing that my vertex is not directly over the center of my base. But don't fret, it's the exact same formula. Nothing about it's going to change. We just need to make sure our height is perpendicular to the base. So our capital B, area of the base, is going to be that pi r squared. So we would be using 3 squared because this right here is going to be my diameter that we would need half of for our radius. So we're going to get 9 pi for our capital B, and then we'll have an h of 2. So my volume is going to be 1/3 that 9 pi times 2, which is just 6 pi feet cubed. Okay, moving into number 7. So for number 7, we have find the radius of a circular cone whose volume is 8 pi inches cubed, and we have a height of 6 inches. So we're going to plug into our formula. So our volume is equal to 1/3 our capital B times our height. So we currently know that our volume is 8 pi, is going to be equal to 1/3 my capital B, area of the base, times my height of 6. So I'm going to go ahead and take that 1/3 of 6 is just going to give me 2. So I'll have 8 pi is equal to 2 times my capital B. And so when I simplify, when I divide both sides by 2, I'm going to get 4 pi is equal to B. Now, keep in mind, we are trying to find our radius. And so rewriting this, my 4 pi is equal to pi r squared. That's my formula for area of the base. And so my r is just equal to the square root of 4, which is going to be 2 inches. All right, so let's go ahead and move on to the back side. We have number 8. So in number 8 here, we are finding x if the volume is 126 centimeters cubed. So here I'm just going to highlight my base. So what we can do here, another way to kind of solve it, like what we've been doing with, for example, the previous one, is I can plug into my formula. We have my volume is equal to 1/3 the area of the base times the height, right? Well, my capital B is just going to be, we've got 1/3 of, we'll have 1/2 my base times my height times h. So I'm going to plug into this. We have our 126 is equal to, I'm going to go ahead and reduce. We have that, or simplify, not really reduce. We have that 1/3 times 1/2 is just 1/6. We have our B times our H, which is talking about for our base. So we'll have the 9 times X times my height of 14. All right, what I'm going to do here is I'm going to multiply both sides by 6 so I can get rid of that fraction. And so when I do that, I'm going to get 756 is equal to our 9x times 14. Okay, and so when I divide both sides by 9, I'm going to get 84 is equal to 14x. And then just dividing both sides by 14, that will leave me with my x is going to be equal to 6 centimeters. All right, moving into number 9. So for number 9 here, we have find the volume of a cone whose radius is 12 feet and whose surface area is 300 pi feet squared. All right, so we have a cone. We are dealing with surface area, so that's where I'm going to start off with. With our surface areas, we want our capital B, which I'm going to use that radius of 12, so pi 12 squared, which gives me 144 pi. I'll have my P, because that's also in our surface area, which is 2 pi times my radius, which is 12, so we'll get 24 pi. And then I can plug into my formula. So my surface area, so that 300 pi, is going to be equal to 1/2 my P, so 24 pi, times my slant height, plus the area of the base. Well, I can't combine these two because I don't have a slant height in the other one, so in the 144 pi. So what I'm going to do is I'm going to subtract that to the other side, And when I subtract that 144 from 300, I'm going to get 156 pi is equal to, I'm going to take half of that 24 to get 12 pi times my slant height. So then I need to divide by everything in front of my slant height. So I'm going to divide both sides by that 12 pi. And that should leave me with 13 is equal to my slant height. Now, for volume, we don't use slant height. And so I am going to need to use that slant height along with my, so let me draw it here, along with my radius of 12 to find my h, my height of this cone. So plugging in, we're going to have our 13 squared is equal to 12 squared plus h squared. We'll get 169 minus 144 is going to be equal to my h squared. And so when I subtract, I'm going to get 25 is equal to h squared. Therefore, my h is just going to give me 5. So now that I know my height, I can plug into my volume. We will have that 1/3 the area of the base, which is 144 pi, times my height of 5. And that's going to leave me with a volume of 240 pi feet cubed. All right, now let's look at number 10. So for number 10, we have that a 120-degree sector is cut from a circle, and it's going to have a radius of 9 inches. The 120-degree sector is rolled to create a cone. Find the volume of the resulting cone. So this is going to be a little hard to kind of explain on here since I don't have a visual much. But what we're doing is we are going to be picking up, in a sense, this sector right here at the center. And when we do that, we're rolling it to match this radius with this radius to form our cone. Now, when we do that, we have to keep in mind that our radius is no longer our radius in this cone from that sector. It actually becomes our slant height, and so my slant height is 9 inches. And what we are going to do to find our radius, sorry, I was blanking, is we are going to notice here that this arc length here becomes the circular base over here. So in a sense, our arc length is going to be the circumference for our circular base. So we're going to start off by finding our arc length. If you remember from our circles unit, that's going to be our m pi r over 180. So plugging into that, our m is the angle, that 120 degrees. They said that our radius was 9. We're going to have over 180. So I can simplify this a little bit. So I see here that 9 will go into 180 20 times. So I'm going to have 120 pi over 20. And that just becomes 6 pi. So keep in mind our arc length is going to be equal to our circumference. So my circumference formula is 2 pi r is going to be equal to that 6 pi. So when I divide both sides by 2 pi, I'm left with my radius is going to be 3. So I'm going to come over here. I'm going to draw my radius of 3 inches. And since we are finding our volume, we are going to need to know the height of this cone. So in order to find the height, we're going to use Pythagorean theorem using that slant height of 9 and radius of 3. All right, so we are going to plug in, we've got our 9 squared is equal to 3 squared plus h squared. We'll get 81 minus 9 is going to be equal to my h squared. And so when we subtract, we're going to get 72 is equal to h squared. I'm going to take the square root of both sides. And so when I simplify, I'm going to get 6 root 2 is equal to my h. Now, for those of you that need to see where I'm getting that from, looking at this over here, I can factor this into 36 and 2. The square root of 36 is where I get that 6, and then I just have that leftover 2 underneath the radical. So now that we know our h is going to be equal to 6 root 2, we need to find our capital B, area of the base. So pi 3 squared, which will give me 9 pi. And plugging into my volume, I'll have 1/3 of that 9 pi times 6 root 2. So 1/3 of 9 gives me 3. 3 times 6 is going to give me 18. We'll have pi root 2 and inches cubed. So the one little key thing I do mention to my classes is make sure that you are putting that 18 pi in front of the root 2 so that in case you accidentally draw that radical out too far, you don't lose points because it looks like it's underneath the radical. All right, now let's move on to our last problem. We have the plane region is revolved completely about the given line to sweep out a solid of a revolution. We're going to describe the solid and find its volume in terms of pi. So for part A, we're going to rotate it about the x-axis. So I'm going to start off by just highlighting my x-axis here. And if you recall from my other video, what I like to do with these problems is I'm going to draw my mirror image of it on the other side of that line. And because we are making a full revolution, we are making a circle around this line. I'm going to just draw a circular base being shown. And you can see that this is turning out to be a cone. So when they ask you to describe it, we can call this a cone. And we're going to find the cone's volume. So to find my cone's volume, we're going to start with our capital B. We need to know our radius for that. So starting from my line that I'm rotating, I'm going to just count to one of those points on my circle, which is going to be 1, 2, 3 away. So we're going to have a radius of 3. So we'll have 3 squared pi, which will give us 9 pi. And then for our h, our height, we are going to have a height of 1, 2, 3, 4. Okay, so finding my volume of this cone, we're going to have 1/3 of 9 pi times 4, which will give us 12 pi units cubed. Okay, that one was pretty simple. Now let's look at part B. I'm going to real quick just come over here and erase what I have so that when I redraw it doesn't get confusing. All right, this time they tell you that we are going to revolve it around the y-axis. So I'm going to start off by highlighting this line. Then, as I mentioned before, I'm going to just draw that same triangle on the opposite side so that it's a mirror image of it. And then I'm going to connect it with a circle so that I can see the shape that is being formed. Remember, it might not be perfect, just to give you an idea. So this one's not coming out very pretty, but you should kind of see the shape that we're going to describe, which is going to be a cylinder with a cone cut out. So let me go ahead and write that. All right, so we're going to find its volume by doing exactly what we have here. We're going to start with our cylinder, we're going to find our cone, and then we're going to cut it out by subtracting it. So starting with my cylinder, so for my cylinder, we're going to have our capital B area of the base. For that, we need to know our radius. So I'm going to start at the line I'm reflecting over, and I'm going to go 1, 2, 3, 4 out to an edge to get my radius is 4 squared pi, which will give me 16 pi. Then we have our height. We're going to just start. Make sure you're not counting where we're drawing that circle. We're counting from the top of the triangle downward. So 1, 2, 3. And so we find our volume by just taking that 16 pi times 3 to get 48 pi. Then for my cone, okay, we have that same B. So we're going to have 16 pi. And then my H, we've got is going to be 1, 2, 3. Yes. So same H. And so for my volume this time, we're going to have 1/3 my area of the base, 16 pi, times 3, which should just give you 16 pi. And then we just subtract. When you subtract, you're going to get 32 pi units cubed.